Can you what?
Can I read it?
Sure, hurry up.
If you want the extra one, turn on homework in before 2
I just can't remember what I put in the thing if I did. If I didn't put any directions in the thing, it has to be before 3 times a day. But I don't know.
Oh, okay, I thought we did that one.
All right, here we go. According to my records, we left off practice test 2, number 7, which is where the calculator part begins. One more time, this test is in 2 pieces. So you'll be doing part of it without a calculator and part of it with a calculator. So, part 7 starts the calculator part. And it says solve. So what are we going to do to solve this guy? Okay, well then hurry up so that you can.
No, he said he's gonna call me like at the end of class.
Oh, okay. So we're going to use a calculator here to solve these problems. Which, anybody have a thought on that one? 5 to the x equals 10. Matthew says, let's loop-de-loo it. Can't do anything with the base 5 logarithm, so let's get rid of it. 5 to the x equals 10. However, you can't get a common base. I know these numbers have something in common, but they don't have a common base. This is not 5 squared. So the only way to solve for a variable is to take a logarithm of both sides. What happens to that x when I take the logarithm of both sides? It comes out in front. And our answer is log 10 divided by log 5. Now we have that thing called the change of base formula. So some of you are going to go straight from here to here if you remember the log of the top number over the log of the bottom number. Every time that's going to work out. If that confuses you, you don't want to worry about it, have too much other junk to memorize, it's fine. Just these are the steps you go through. So we type it in our calculator. Does it say anywhere how to round? On the other practice test, it said round to the 1,000th. So I have a feeling the test will say the same thing. So we're going to round to the 1,000th. So log 10 divided by log 5. I got 1.431. Remember, how many decimal places is the 1,000th? 3. So, turn around to 3 decimal places. All right, what about this guy? Exactly. Here we go. Is there a common base between 2 and 5? Nope. So the only way to solve for an exponent is to use logarithms. So we'll log both sides. And what did we do that for? So that we could pull this guy out here. So x log 2 equals log 5. And we got the log of 5 over the log of 2. These two problems are very similar, aren't they? Very, very similar. Log 5 divided by log 2. Did you get 2.322?
Yep.
Please be typing in with me. It's what I knew would happen when I look at the quizzes from yesterday. Some of you can get everything set up nicely, but you don't know how to type it in because you're not practicing. Make sure you're practicing. All right, what about C? Divide by 5. So e to the 0.13x equals 12/5, which since you don't have to round it off, if you want to write that 2.4, you certainly can. Either leave it as the fraction, 12/5, or write it as a decimal. Now what? We got an E, so we're going to ln, and we're lning because this will disappear.
Yep.
So 0.13x equals ln 2.4, and x equals ln 2.4 divided by 0.13.
6.734.
I'm sure you're right. You are. 6.734 if we're rounding off to the nearest thousand, 3 decimal places. So far, so good, James? What? Oh, shoot, I didn't turn it on.
Well, I see
What the heck does that mean? Does that
It's
mean
the
it's
same
not running?
notification that was yesterday.
Why does it do that? I don't know. I think it's still, I don't know. The top clock is still going, so hopefully it's running. Thank you, James, for pointing that out. Okay. That's it for that, so now we're on the back, right?
Yep.
Okay, so now we have our word problems. I would recommend that the first thing you do on your test when you get to this page is at the top of the page, write down your 2 formulas. It's time to have these memorized now, guys. They're easy. PERT especially is easy. PE to the RT power. That's easy, PERT. This one's a little harder, but we've used it a lot, so hopefully you're getting used to it. All right, so now I got both formulas written down. Problem A. What interest rate is required to double an investment in 11 years if the interest is compounded monthly? There's another one over there, if that one didn't work, Vegas.
You know what, I just got a mechanical pencil you can use.
All right, so what formula am I using for problem A? The second one. So I'm gonna write it down. And I'm gonna start plugging in stuff. So what am I putting in for A? I don't know, but it's gonna be double P, right?
Yeah.
So since they didn't give me either
Just choose a
one,
number.
I'll just make one up. So I'll let P be 100, and then A will be 200. If they don't give you a starting amount, make up your own. Just make sure that the ending amount is double it, since we're doubling in this case. What interest rate is required? So I guess that's my variable. And N is 12, and T is 11. So what's 12 times 11? 132, so I'm gonna go ahead and take care of that right now. If you have a double exponent, you gotta be really careful putting that in your calculator, so it's usually easier just to combine them before you get started. Okay, now what? Divide by 100, absolutely. And what's gonna happen, no matter what numbers you started with,
Yeah,
when you
always
do
get
the
2.
division, you're gonna get 2, right? Now somebody is gonna do logarithms on this problem, and it's gonna be a very bad move. We don't need, oh, you can take the log of both sides, but you don't want to. The only reason you take the log of both sides is if your variable is up here, right? It's not. So I need to get rid of that 132, but I'm not gonna use logarithms. What am I gonna do?
132 root it.
I'm gonna 132th root it. That's exactly right. Because that will leave me with this over here. Would you agree?
Yeah.
It's like square rooting, only we're 132th rooting. And everybody should know how to put this in on the calculator because we've talked about it. 132 math. Go down and get the X root button. You need the X root button. T. You should have gotten 1.005. Did you get 1.005?
Yeah.
Now that's this number. That is not the answer to the question. That's this number right here. So we're going to have to subtract the 1. So just minus 1. And then times by 12. And you should end up with R equal to 0.063. Which in terms of a percentage is 6.3%.
Yep.
So again, no logarithms in this problem. You got 132nd root it. As soon as you get the 132nd root, you're trying to get R by itself, so you'll subtract 1 and times by 12.
What did you get for your underradical?
It was 1.005.
Yeah, that's what I got.
All right. How much will be in the account at the end of 12 years if $10,000 is invested at this interest compounded quarterly? Which formula?
Second one.
Same one, right?
Natalie.
Everybody understand why it's that one? Compounded quarterly? All right. What do I put in for A?
You're solving for A.
Solving for A. I want to know how much I'm going to end with. What do I put in for P?
1,000.
10,000, I think.
That's what it said.
What's my interest rate?
2.1.
So 0.02175 divided by 4, because it's quarterly this time, and it's 12 years.
12, that's 48.
So my exponent's just going to be 48. Again, do you need logarithms?
No, I just solve it.
Just solve it. Just type it in exactly the way we wrote it. 10,000, make sure you get enough zeros. Parentheses 1 plus 0.02175 divided by 4, close parentheses, raised to the 48th power. I got $12,973.10.
Yep.
All right, and C. What is the growth constant for logarithmites if a population of 432 grows into 987 in 15 hours? Formula?
The first one.
Yep, you need PERT for this one. Any population problem is going to use PERT. What's A?
987.
987. What's P?
432.
432. E is E. Do not plug stuff in for E. E is just E. What's R?
You're finding it wrong.
Don't know what R is, but T is 15.
Yes.
So it looks like that.
Yep.
Are your logarithm radar flashing?
Yeah.
You're going to need logarithms here because look where your variable is. It's up there in the exponent location. Okay, so we're going to use logarithms, but not yet. What has to be first? Divide. So we're going to have 987 over 432 equal to E to the 15R.
Yep.
ln both sides. And of course, what's going to happen as soon as you ln over here on the right?
You come up with only 15, right? Because with ln and e.
So ln that fraction equals 15R.
Yes.
So what we're gonna type into our calculator is ln the fraction divided by 15.
Yes.
So ln the fraction, don't forget to close the parentheses, divided by 15. Did you get 0.055? Now, it's okay to leave it as 0.055. That is the growth constant. Sometimes growth constants are given as percentages. So if you did want to change that, I would probably just leave it as 0.055. But if you did want to change that to a percentage, what would it be? 5.5%. Any questions about that? You feel okay about that? All right, we got one more to go, gang. One more. Here we go. Practice test 3. Notice, what does it look like? Practice test 1 and practice test 2. What do you think your paper is going to look like on Tuesday? This, exactly. All right, so number 1, here we go. Is it growth or decay?
Growth.
Growth. How do we know it's growth?
It's bigger than 1.
This number right here is bigger than 1. This is the number you look at, the one that the x is hooked to, the base of the exponential. It's bigger than 1, so it's growth. How much bigger than 1 is it?
8%.
8%. So B is 8% growth. What is the initial value?
16.
A, this is A, B to the x. A is your initial value.
Oh, that's a 0.
Okay, number 2. We have 2 points, 0 2/3 and 2 3/2. And we are gonna write an exponential. So we've talked about this many times. Remember, A is the y-intercept. It's the y value and the one with the 0. So A is 2/3. So we already know y equals 2/3 times b to the x. So we already have half credit. Right now, what happens?
You multiply.
Take the x.
We don't multiply by anything
Plug
yet.
in the x.
We plug in this point,
Oh.
x and y.
So 3/2.
So 3/2 equals 2/3 b to the second.
Square root.
No, I don't square root yet. What do I have to do?
Multiply the 2.
Always, I gotta get rid of this number, right?
Yeah.
Yes.
Now it's a fraction, so I'm thinking I could divide by 2/3, but it might be easier to multiply by
The reciprocal.
the reciprocal, which is 3/2. I have to get rid of this number right here. So if I multiply it by 3/2, it'll be gone, right? So 9/4 equals b squared. I know they're fractions. Keep in mind this is no calculator, so you're gonna have to be able to deal with that.
Which equals 2 3/2.
So what do I do now?
Square root.
Now I square root it.
Get 3/2.
So if I square root it, b equals 3/2. So y equals 2/3 times 3/2 to the x. Any question about that? Alright, why don't you take a couple minutes and see, A through J, see how many of those you can figure out. A through J. See how many of those you can get before you'll put them on the board and you'll see how many you got right. Huh?
I got cut.
Yeah. Right, wait a minute, I think I need to send you the task. We're gonna talk about it. We're gonna talk about it.
I'm an idiot. Oh my god, I can't for you anything. No, you did that right. I did it wrong. I was like, I don't know what I was supposed to write. I literally tweeted about it today? I will. Wait, is your mom leaving? I can take you in my house. I'll go play with them.
You guys got the A through, J done, Emma? No, and quit padding. I mean, if you're helping each other with the problems, that's fine, but I don't want to be talking about other extraneous stuff. Yeah, I have the first column done, so A through E. When you get ready, double check. Check your answers. First of all, make sure I'm right. And then if we don't match, let's talk about why for the first 5.
Where's the Excel time?
Whoops,
Yeah,
right
the
mistake.
X, yeah, the X. The X should be on
Oh,
the
yep,
bottom.
the X should be on the bottom, thank you. You are exactly right. Is that better?
Yeah.
You are exactly right. Some of these, like D and G and J, there's not even any work to show, is there? Aren't those just automatics?
Yeah.
We all should get those right. Let's not miss those. You don't have to do anything except just write the answer down. Because in all these cases, stuff cancels.
equation came up.
Thank you. I don't know if that interferes with the, thank you for checking. All right, so what do we need to talk about here, A through J? What do we need to talk about? James?
Is there a difference between D and J, like?
D
Yeah.
and J,
Like
no.
E and then, just E with the.
No, if any time, no matter what order they're in, if E and LN are touching, no matter which one comes first, E or LN, if they are touching each other, they're gonna cancel.
So even though it's
Exponent,
exponent, it's
yep.
still touching each other?
Yep. Yep. Anyone else? Okay, so I guess I'm supposed to know then that everybody gets all these. No issues. Bo? No issues?
Pretty good at it.
You're pretty good at it. Love it. Awesome. Okay. All right, well, what's on the next page? This is more no calculator, but these are equations now. We're going to be solving these equations. So before we start, I want to remind you of two things. First of all, if you have an equation,
Precal stops for nothing.
absolutely not. We have security lights. We're not even worried. It used to be scary back in the old days because when the lights went out, it got real dark. But now we have the security lights, so we don't even care. If you have an equation with logarithms in it, you can't have more than one on each side, right? So if you've got two logarithms or more on a side of an equation, you have to put them together. The second thing is, there are two kinds of logarithm equations. There is this kind, and there is this kind. If it's this kind, where there's only one logarithm on one side, you loop-de-loop.
Yeah.
So this would be 7 squared equals x. If you have one logarithm on each side, then you can get rid of them and say x equals 2. Those are the only two kinds of logarithm equations there are. So in all of the equations on this page that have logs in them, you're either going to loop-de-loo or you're going to cancel the logs after you have done any condensing that you have to do. All right? This was a bugaboo on the quizzes we took the other day. So we got to make sure we're clear. You got to condense first, and then you're going to have one of these two options. Loop-de-loo it or cancel the logs. Do not cancel that logarithm. You can't say x equals 2 up here. All right, so let's see what we got with A.
I think we
Down
should
here on the
loop
right
do
side. So what do we do with A?
Loop-de-loop.
Loop-de-loo it. You got one logarithm on one side, so you're going to loop-de-loo it. So we will say 2 to the third equals 2x minus 1. 2 to the third is 8. Add 1. Divide by 2. Any issues with that? This is no calculator. You don't need a calculator. You got it. All right. B. No logarithms in this equation. How do we solve something like that? Divide by 5, always get rid of that extra number. So 160 divided by 5, oh my gosh, I'm probably gonna have to do it over to the side. No calculator, you don't need a calculator, you can divide. Now, you might be thinking about taking the logarithm of both sides, and that would be fine, but this is no calculator. So 4 and 32 are not random numbers. It's not like 4 and 17. What is special about 4 and 32? They're both powers of 2. So we'll think of this as 2 squared, and we'll think of that as 2 to the 5th. So can we say 2x equals 5?
Yes.
So x equals 5 halves. Everybody still on board? Olivia, you all right over there?
Yeah,
Okay.
making do with what I got.
All right. Now what? Divide by -2. Absolutely. It's an extra number. Get rid of it. Now, you have one logarithm. The only way to solve it with one logarithm is to loop-de-loo it. What piece of information is not written up here?
10.
The base is 10. So 10 to the -2nd equals x. What was 10 to the -2nd mean? What does that mean? 1 over 10 squared,
Yes.
which is 1/100th.
Yes.
All right, let's look at the next one. We are so prepared down here. We have security lights, our own radio.
What are security lights?
They're run by the generator, so when power goes out, they stay on.
Are they on
It gets
now?
dark.
They're on now.
Oh wait, so everything else is dark?
So
So there's no
if,
power everywhere?
like, if the power went out, it would be like turning the lights down. This is as dark as it gets in here, because those lights stay on all the time.
If the power's out, how's the AC running?
It's not out.
Well, the power isn't out. It flipped. But if the power does go out, those lights will go off, because these will stay on.
Oh.
Did they just put those in? Or have they always-
Last year. Okay. I don't know if you guys remember, but I think it was last year, in the fall, there was a really bad storm and tornado, and was that 2 years ago? And they made everybody come in, and we had to be down here. And on the lights out in the hallway, the buzzer things, they had security lights, but they only had a life of about 30 minutes. So first that one went out down there, and then this one went out, and it was black down here. And we had like 400 kids, everybody from that girls' soccer came, everybody came down here. And the power was out. We were stuck. They wouldn't let me leave because it was still tornado warnings outside. So we were trapped down here for like 2 hours, and it got very hot, and it was very dark. We had our flashlights, but they didn't work very well.
I was stuck in the football locker room.
It was, yes, that was the other place. Everybody was either down here or in the football locker room.
Physics room was packed too.
And, yeah, in the basement area.
Coach,
yeah.
football locker room?
Oh, it was gross.
So anyway, so after that, they put in the security lights, which was a great move. Okay. All right, so this looks like a very complicated problem. What do you want to do first?
Go 1/8.
Multiply both sides by
1/8.
8. No, not by 1/8.
Oh.
You can divide by 1/8, but that would be the same as timesing by 8. You need to make that number number go away, and timesing by an 1/8 won't do it. You need to multiply by 8. So 2 to the 3x over 4 power equals 64. No loop-de-loos. There's no logarithm
You
here.
wanna get to the power thing.
What do we know about 64?
It's a
Power
root.
of 2.
It's a power of 2, and you may not know, or you may know, but 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another one is 32, so another one would give me 64. So 1, 2, 3, 4, 5, 6, 2 to the 6th.
So 3x over 4.
Another way to think about that is 64 is 8 times 8. How many 3's make an 8? How many 2's make an 8? 3? So you have 3 and 3, you got 6 on one together.
You can tell the answer.
So now we can say 3x over 4 equals 6.
Multiply by 4.
So 3x equals 24
Divided by 3.
X equals 8.
and x equals 8. Very scary looking problem, but if you think about changing it to a power of 2, it's not bad. All right, here we go. Caitlin, what's wrong with this equation?
It's 2 logarithms.
2 logarithms. So somehow they have to go together to make just one. Notice the way Mrs. Ford writes that. She writes a logarithm and then puts a parentheses. Because in the parentheses has to go the 2x and the x plus 1. What are we doing to the 2x and x plus 1? Dividing. So 2x over x plus 1. We are dividing because that is a minus. Okay. So now I have one logarithm on one side. So what do I need to do? Loop-de-loop. So 4 to the 3rd equals 2x over x plus 1. We are not going to be afraid of this. Do you hear me? We are not going to be afraid of this. We are going to say, okay, 4 to the 3rd is 64. We're going to get rid of that fraction by timesing both sides by x plus 1. It's going to be a distributive, so make sure you multiply both of them by 64. So regular equation. Don't we have to have all the x's on the same side?
Yeah.
So I'll subtract 64x. So I'll have 64 equal to negative 62x. So x equals 64 over negative 62.
Yeah.
Which reduces to 32 over negative 31.
Sure.
Which is extraneous. This problem has no solution. We did all that for nothing. Why is it extraneous?
Because it would make it negative.
Because if you put it right here, wouldn't that be a negative?
Mm-hmm.
And can you take the logarithm of a negative?
No.
No.
You can't. All right. Got time to do a couple more. And we'll finish it up tomorrow. All right, so log base 3, x plus 1, minus log base 3x equals log base 3, 5. Kyle, what is your thought when you look at this problem?
Half right.
Huh?
Half right.
Yeah,
Combine the
Yep, these have to be put together. So again, we're going to have one log one log over here. Somehow I have to combine the x plus 1 and the x. X plus 1 over x. Would you agree, class?
Yeah.
Now what? We can just drop these, right?
Yeah.
So x plus 1 over x equals 5.
Multiply by x.
X plus 1 equals 5x.
Subtract from x.
1 equals 4x, and x equals 1/4. Is that okay? Four to the x equals 8. What do you think? 2 squared to the x
equals 2 cubed.
equals 2 cubed.
So 2x equals 3.
Oh my gosh, that was easy.
Jeez, we're moving along.
We are moving along. Ln x equals 2.
Base E.
The base is e, so e squared equals x, and that's your answer. That's all. That's it. And then I, oh my goodness, another very simple one.
49.
7 to the second equals x, so the answer is 49. Let's do 5 and 6. These are the last no calculator problems. Single logarithm. So number 5, we are writing a single logarithm. So write a single logarithm. What's going to go in the parentheses?
X over y cubed.
X over y. First of all, why are we dividing? Because it's a subtraction. And what are we going to do with the 3? It becomes an exponent on the y. Because it's in front of the y. Everybody okay with that? Really no work to show there, just write your answer. And then 6 is the opposite. When you split it up, remember that you have to have a log x and a log y. You have to have a log for each letter.
There'd be 2 log x plus 3.
2 of these because of that, right?
Plus log y.
Plus, because that is a
Multiplication.
multiply. And that's all there is to it. So tomorrow we will finish the, we'll do the calculator part.